Welcome to The Explainer. Today, we're uncovering a secret algorithm that was born during the atomic age and now, believe it or not, powers just about everything, from your Netflix queue to the search for new medicines. It's become this hidden engine of our modern digital world. Now, before we even give it a name, I want you to just absorb this quote. You see, experts don't just call it an improvement, they call it a full-blown revolution. It didn't just give us new answers, it fundamentally rewired how we even think about solving the world's most complex problems. Okay, so here's our game plan. We're going to start with its secret origins, back in the atomic age. Then, we'll tackle the mind-bending problem it was designed to solve. After that, we'll break down its genius logic, see it in action today, and we'll wrap up with a really critical question about the future of all this technology. So, our story kicks off in the 1940s at the Los Alamos National Lab. Yeah, the very same place where brilliant minds like John von Neumann and Stanislav Ulam were working on the atomic bomb. But they were also wrestling with another, totally monumental challenge. What's just wild here is how fast this all happened. In the 40s, you have the initial spark of an idea from Ulam and von Neumann. Just a few years later, von Neumann is already using one of the world's very first computers, the ENIAC, to test it out. And then, bam. By 1953, we get the Metropolis Algorithm, the first official version of this incredibly powerful new tool. So what was this giant problem they were up against? Well, it's something statisticians call the curse of dimensionality. And trust me, it's just as daunting as it sounds. Okay, think about it like this. Imagine you're trying to find the best route for a delivery driver. With, say, 5 cities, it's a piece of cake. But with 50 cities, the number of possible routes is literally greater than the number of atoms in the known universe. That's the curse. You can't just check every single option. You need a much, much smarter way to search, which is why this new way of thinking was so desperately needed. And that new way of thinking? It's called Markov Chain Monte Carlo, or as everyone calls it, MCMC for short. Now, the name sounds super complicated, I know, but it's really just a clever combination of two pretty simple ideas. Let's break them down. So, on one side, you have the Markov chain. Just picture a drunkard's walk. It's a random path where your next step only depends on where you are right now, not the whole path you took to get there. Then, on the other side, you have the Monte Carlo part. This is kind of like political polling. You use a small, random sample of people to get a surprisingly good idea of the bigger picture. MCMC cleverly smashes these two ideas together. All right, let's focus on that Markov chain for a second. That memoryless property, that is the absolute key. Imagine you're playing a board game. The only thing that matters for your next move is the square you're on right now, right? Not the 5 squares you landed on before. Every step is a fresh start, totally influenced only by your current position. Now for the Monte Carlo method. This is where the real magic of randomness kicks in. See, instead of trying to do one single, perfect, and incredibly difficult calculation, you do thousands of easy random guesses. Now, individually, each guess might be way off, but when you average them all together, you get a surprisingly accurate answer. It's like finding wisdom in a crowd of guesses. So how does this all fit together? Well, it's a super smart search. You start at some random point. Then, you propose taking a random step to a new point. Then, and here's the genius part, you figure out if that new spot is better or more likely to be the right answer. If it is, you move there. If it's not, you might still move there anyway, just once in a while, to keep exploring and not get stuck. You repeat this thousands and thousands of times, and the process just naturally ends up spending most of its time in the best, most probable areas, and that gives us our answer. Okay, I know this might all sound a bit abstract, but this atomic age tool is now a totally practical weapon that's used every single day to protect our digital world. So where is this old school algorithm playing hero in the modern day? A huge one is cybersecurity. Let's look at 3 really critical areas where MCMC is our secret weapon against all sorts of digital threats. First up, cracking codes. MCMC lets analysts find that needle in a cosmic haystack. Instead of trying every single decryption key, which, by the way, could take centuries, it intelligently wanders through the massive space of possibilities to crack complex codes in a fraction of the time. Second,
Think of it like a digital detective. It can spot an intruder in a super busy network by looking beyond the obvious. It builds a model of what the network's normal hidden state should look like. The usual ebb and flow of data. And then it spots the tiniest little anomalies that signal an attack, things a human analyst would almost certainly miss.
And third, it's a guardian of our privacy. It models network traffic to understand and strengthen the anonymity of systems we rely on, like the Tor network. It essentially stress tests them from the inside out to find and patch up vulnerabilities before the bad guys can find them.
But, and this is a really big but, the very power of MCMC to solve these incredibly complex problems, well, it leads us to a profound and very modern dilemma.
And here is the paradox. The very thing that makes MCMC so powerful, its ability to navigate this immense complexity, it creates a totally new problem. We are now building models for finance, for security, for science that are so intricate no single human can fully wrap their head around how they work. We're literally creating black boxes, and we're starting to run our world with them. Which leaves us with a critical question for our future. How much faith can we really place in the answers these black boxes give us? As this atomic age secret continues to shape our world, the biggest problem it leaves us to solve might just be the problem of trust.